We're going to take a look at a really nice differential equation type of question here from the AP Calculus curriculum today. And it's a question where it's easy for us students to get lost in the context, like the flowery context that describes the scenario is easy to kind of get lost in today. But I think when we can boil it down and get right to the math involved, the calculus involved, this is a very manageable, a very doable question. So we're going to kind of help you cut through the weeds, so to speak, and really focus on the heart of the matter. So we're revving up for the AP Calculus exam. We're working through the 2017 packet, and this is question number 4. It is a non-calculator question. So the first thing that I noticed was we've got a nice boiled potatoes taken out of a pot on a stove and left to cool in the kitchen. Now, when it was first taken off, the temperature is 91 degrees Celsius, and that temperature stays above 27 forever. And so if I was here's what I'm picturing in my mind, if nothing else. That initial temperature is 91, and it's never going to get below 27. So it's almost like there's a horizontal asymptote here. So if I was graphing the temperature of that potato, it might look like this, where that temperature drops pretty rapidly at the beginning when you first set it on the counter, and then it begins to kind of taper off as it approaches a temperature of 27. So what we've got here is, let's see. I'm right here. The internal temperature of the potato can be modeled by function h, which happens to satisfy this really fun differential equation. So think of this in your head. H is a function that models or measures the temperature of the potato, and therefore the derivative of h with respect to t measures the rate at which that temperature changes. Okay? So we want to come up with an equation for the line tangent to h at t equals 0. So I'm thinking I need h of 0 and I need h prime of 0 to be able to write my tangent line. Now we already know that h of 0 is equal to 91. That's already been given to us. So now what I want to do is I want to evaluate that dh dt function specifically at 0, 91. And what you want to be really careful of here is that you substitute the 91 for h, and we don't carelessly substitute the 0 for h, because I can see myself doing that. It's just normally that, like that x or that independent value is the one that gets substituted, but we want to do 91 minus 27. Now, this is non-calculator, so 91 minus 27 makes 64. And then 64 multiplied by negative 1/4 is going to make negative 16. All right, so if I put it all together here, my tangent line says y minus 91 equals negative 16, and you could use x or t right here, minus 0. And we do want to use that equation to approximate the temperature, the internal temperature at t equals 3. So I'm really running out of room here, but we're going to try to cram it in. Y minus 91 equals negative 16, 3 minus 0. And negative 48 plus 91 is going to make 53, I believe. So now the last finishing touch I want to put on here, I want to say, therefore, h of 3 is not equal to, but it's approximately 53 degrees Celsius. Huge emphasis on the approximation sign there. Now, I really like part B. Now, I am sad to report to you that B was only worth 1 point on the College Board's rubric, and I don't necessarily disagree with that, but it's heartbreaking that that's not worth more points, I guess. We want to use that second derivative of h, which we'll have to calculate, to determine whether our answer, that 53 degrees Celsius, is an underestimate or an overestimate of the actual temperature. So first things first. Now, the first derivative of h, I'm going to distribute that negative 1/4. I'm just a big fan of distributing if I can before I take this next derivative. So now, when I take this next derivative, I have to continue to remind myself. dh dt is in terms of h, and now I'm attempting to derive that function with respect to t. So watch what I'm going to do here. I'm going to put a parenthesis around h and make the exponent of 1. This is strictly for emphasis, to remind myself that I have to execute the chain rule. So if I multiply the exponent times the coefficient, keep the inner function, raise it to the 0. Now multiply by the derivative of that inner function. You're basically getting negative 1/4 times dh dt when you're all said and done. Now, a lot of times what I would recommend at this point is you take this expression for dh dt and you substitute it in right here. But I don't know if that's necessary here in this case. So what we're going to try to do is we're going to try to evaluate the second derivative of h at the point of tangency, which was 0.91. And what you know is you already know that the value of dh dt was a negative 16 at this particular point. So that's why I say it's not necessary to make that substitution. Negative 1/4 times negative 16, that gives me a positive 4. Now, because the second derivative of h is positive, that implies that function h is concave what? Concave up. And if h is concave up, any tangent line drawn to that function lies below. So our tangent line lies below h. Therefore, h of 3 is going to be greater than 53 degrees Celsius, because what we're saying is that 53 we got from part A is an underestimate because the tangent line lies below h. So there's a lot of reasoning and thinking that goes into that question, and like I said, unfortunately it's only worth 1 point. So where are all the points hiding? Well, they're hiding in part C here. So we're going to make sure that we feel good about getting all these points. For t is less than 10, there's an alternate model for the internal temperature of the potato, and it's given by this differential equation. So basically, we're throwing dh dt out the window for now, and we're going to use exclusively dg dt. And we're going to, first of all, find an expression for g. In other words, our task right now is to solve the differential equation, and we're going to use a method called separation of variables to get that done. Now, as I separate the variables, here's maybe your first move. I'm going to divide both sides by the quantity g minus 27 to the 2/3. But I'm going to leave the negative on the right-hand side, and I'm going to multiply the dt over there. Now, leaving the negative on the right-hand side is not mandatory, but I do recommend that. So really what I want to do is I'm going to rewrite the left side so that my exponent is a negative 2/3. You always want to move everything to the numerator. Whoops, that's a g, equals negative dt. All right, so now that I've separated my variables, what I want to do now is I want to integrate both sides. And I'm going to have to do a little u sub here. I'm going to let u equal that inner function probably. And your du is equal to dg. And so you're really integrating u to the negative 2/3, which is going to give you u to the 1/3 times 3. So when this integral on the left side is all said and done, I'm going to kind of cut right to the chase here. The left side is going to be 3 times the quantity g minus 27 to the 1/3 equals negative t plus the constant c. Very, very important that you have that plus c in there. Otherwise, that's going to limit how many points we have the potential to earn. Now, what I like to use is this initial condition right here. I'm going to plug that in right now to find c. So I've got 3, I've got 91 minus 27 to the 1/3 equals negative 0 plus c. Now, again, 91 minus 27, we did earlier, 64. And the cubed root of 64 makes 4. 3 times 4 makes 12. So 12 equals c. So I'm almost there. I've got my constant. Really, the only thing left to do now is to solve that solution for g. So 3 quantity g minus 27 to the 1/3 equals negative t plus 12. I'm going to go ahead and divide everybody by 3. I'm then going to raise both sides to the 3rd power and then eventually add over the 27. So it might look like this. 12 minus t, I'll switch the order there, raised to the 3rd power plus 27 is my final solution for g. So 5 points for part C, and it all starts with separating the variables, and then we've got to be able to integrate both sides. We're going to find that constant and then solve for g. So you can kind of think of it in those 4 steps. So hope that question makes some good sense to you. Keep chugging, and we'll talk to you soon.